I always like being prepared for math competitions. I do that by making sure my pencil pouch always has exactly one pencil, always has one pencil and one eraser. I've got a total of 4 distinguishable pencils. By distinguishable, I just mean that all the pencils are different. And I've also got 2 distinguishable erasers. I would also like to mention that pencils and erasers are different. Since I don't want to be thwarted by a lack of pencils and erasers, in how many ways can I prepare my pencil pouch with 1 distinguishable pencil and 1 distinguishable eraser from 4 distinguishable pencils and 2 distinguishable erasers? This is a mysterious problem, and what I like to do with mysterious problems is to try to dive in and see if there's any patterns that will help us trivialize the problem. Why don't we start by doing casework depending on which pencil goes into the pencil pouch? As a result of the pencil that goes in, we can pair it with an eraser, count how many ways to do that for each case, and compute the total number of ways to form our pencil pouch. Let's start by denoting our pencils P1 through P4. P1, P2, P3, and P4. These subscripts just help us denote that the pencils are distinguishable. Let's define our erasers as E1 and E2 in the following manner. Let's start by placing P1 in the pencil pouch. Which erasers can be paired with P1 to create a full pencil pouch? Well, it doesn't matter which eraser goes in with P1, so there's 2 options that can go in. There's 2 options. Similarly, if we place P2 into the pencil pouch, there's also 2 options that can go with P2, E1 or E2. So that would be another 2 options. So we notice that for each of the 4 pencils that we place in the pencil pouch, there's 2 erasers that can be paired with each of them to form a complete pencil pouch. Thus, for each of the 4 pencils, there's 2 erasers that can be paired with it to result in 4 times 2, or 8 total ways to form a pencil pouch. We've discovered a very important theorem in the world of counting, the fundamental theorem of counting. It states that if one event has m possible outcomes and a second event has n possible outcomes, then there's m times n total possible outcomes for the 2 events to occur simultaneously. Before I continue, I feel it's important to cover the concept of independent events. 2 or more events are independent when the outcome of one event does not affect the outcome of the rest of the events. In this example, with our pencil pouches and erasers, which pencil we place in the pencil pouch doesn't jurisdict which eraser will be placed with it to complete the pencil pouch. This is definitely an independent event, then. With this newfound tool to include in our problem-solving toolbox, we've developed great power. Use it wisely, and we can take over any counting problem. I have an extension on this problem. Try finding the number of ways I can form my pencil pouch with 1 pencil, 1 eraser, and 1 Sharpie, which I'll denote SH. If I have 4 pencils, 2 erasers, and 3 Sharpies. Okay. Remember when I mentioned independent events? Dependent events are also an important aspect to learn about when solving counting problems. 2 or more events are dependent when the outcome of one event judges the outcome of another. Let's look at a common problem which requires an understanding of dependent events. The AMC, or Alien Mathematical Conference, is running an election for a president. I always like to write down the information I'm given to solve problems. It makes it easier. So we have our president, our vice president, and a secretary to represent them in the Alien Invitational Mathematics exam. The three positions, president, vice president, and secretary, are distinguishable. Considering that there's 20 total aliens in the AMC, 20 total, and no alien can run for more than one position, in how many ways can they select their positions? President, vice president, and secretary. This problem is different from our favorite pencil pouch one, since the positions are not independent. When one alien takes a spot for president, so one alien can take the spot here, there's only 19 left to take the spot of vice president. This occurs since already one alien is taking the spot for president, and since no alien can run for more than one position, there's 19 left, since one is taking the role of president. So how do we solve this problem this time? Well, let's try using constructive counting to solve this problem. Basically, we'll try to construct how we can form the positions. So, for the president, there's 20 choices for who can take the president's spot. Each of the 20 aliens is eligible to do so. Now, for the vice president, there's only 19 choices left, since I mentioned that the president takes up one spot. Finally, for the secretary, there's 18 spots left. Now what do? We can't just add these, that wouldn't make any sense. So let's go back to our pencil pouch example. For each of the pencils that we placed in the pouch, we had 2 erasers to go with it. That means for each of the 20 presidents, there's 19 possible vice presidents that can go with it. For each of the 19 possible vice presidents, there's 18 possible secretaries that can go with the 19 possible vice presidents. Hence, this 20 times 19 times 18, or in other words is 180 plus 162 would be 342 times 20, which is 68. 40 total ways that the AMC can choose their positions, president, vice president, and secretary, to represent them in the Alien Invitational Mathematics exam.